Hey guys, welcome back to Sega Reverse Engineering. Today we're gonna work view a childhood game of mine on the Sega Genesis, Phelios. It's a vertical shooter. Um, I want to look into how the enemies in the game are spawned. I know, for instance, that many platformer games, such as um, Sonic the Hedgehog series on the Sega Genesis, 1, 2, 3 Knuckles, use a object placement list. This one's from the disassembly from Hive Brain of Sonic the Hedgehog 1 of Green Hill Zone 1, and it contains each object in the levels, X and Y coordinates, among other things. And when the object is in the player's spawn zone, it will spawn it. However, not all games use this system. Some, like I've seen some shooters on the Sega Drive, use timers, and I wasn't familiar with this as much, so I wanted to investigate how exactly do these timers work to spawn the enemies that wasn't supposed to do that. You weren't supposed to see that yet. How exactly do the timers make the next group of enemies appear, such as those Firebirds and the Skull guys would throw in the axes, and then next thing of the more Firebirds and such and such. The dragon, and then these birds. So how does that all work? How does it go from one subroutine of how does it go from one group of enemies and their subroutine to the next, and how to know which one to go to and what their action is going to be? Like these guys, they're coming over here and shooting you with arrows and then walking away. And these guys do the same thing. How does the timer do that? So I started digging into stuff. I found I did a RAM search for an object's Y coordinate, knowing that as the object comes further down the screen, the Y will get greater and greater and greater and greater and greater. And then I froze it, and I found that that was the RAM address for the player's Y, because when I froze it, it just stood there. It didn't move anymore downwards. And then from there, I found out its X coordinate, and then I found out what the offset for the X and Y is for it, and then I realized what its base is, and then what I determined what is the start address and the end address of the object memory in RAM, and how big each slot is, and the subroutine that finds the next slot. Um, so I did all this to kind of understand the object RAM stuff for like enemies and just other objects. And then after that, I figured out what was the action, what was the thing that caused the next group of enemies to appear, to be created and do their little thing, and how, what was it that caused that, and what causes them to do their little movement, their thing, like these like I said before, like these skeletons coming to the left and then throwing the axe, and then coming down and throwing the axe and coming down again. What what how does it know what subroutine to do the next action for these things? So I started digging in IDA, and I found a create object subroutine that finds an empty slot, and I a pointer. I found a couple things. I found in RAM a variable that is a timer, and then a kind of some other kind of variable, and it appears that when um, one of the var- one of the values, if you take it and then so if you take the one of the RAM values points to a ROM address, and if you take the word at that RAM address and shift it 8 bits, if it if the other value, which is a counter, is equal to that value, then it goes to the next enemy, it appears. And this value, the second value, the counter is incrementing up. So if it's getting to that value, and if it's not gotten to it yet, it's just going to keep on incrementing until it gets to that value of this pointer's the address at this pointer. I guess uh, the address of the address of the I don't know how to say it, but I'm not going to try and get too mixed up in my words. But it's a little bit. It's like a double pointer. So you have a long word to an ROM address, and then um, the word at that address um, shifted 8 bits as compared to this counter. Um, so that's how it works. So I wrote an overlay script that shows each objects or enemies object or enemies first their the base address and object RAM for the object, and then second its subroutine address, which is stored in the first 4 bytes of its base or of its base address and object RAM, and then its X and Y coordinate. So you can see here that in action. Pretty cool. See these birds. So you can see that this red bird here, it's at slot base FFE500, and its subroutine is C9DC, and then you see its X and Y. And then this other bird, it's at a different RAM slot, FFE540, but it's got the same subroutine because it's a bird, so C9DC. Um, so that's just kind of cool. And then you see the skeletons; they all have the same. Well, they all have the same subroutine, but their slot and object RAM is obviously different, and their X and Y is different. And then same thing with on different levels. The different stuff going on. You can see everything. Um, so I one last thing I wanted to show. I don't fully understand the timer thing yet, but I found an a list of addresses for the enemy's object subroutines starting at this address. And one thing that I wanted to test that was I wanted to say, let's put this dragon here. Let me redo that. Let's put this dragon here, this red dragon, uh, replace it for every enemy. Let's make every enemy that dragon. So we know it's his subroutine is C6EA, right? So, and we know that it starts at 7. So basically what I'm going to do is I'm going to copy that 6 or C6EA subroutine. I'm going to overwrite it and every single of these long word addresses here in this list so that all the objects subroutine, all the enemy subroutines are that for that red dragon. So I'm going to do that in the hex editor in the emulator. So I know that this list starts at 7B9A. Let me move this over just so I can see this. So I go to region ROM FF7B9A, and I copy it'd be OOC6EA. So and 7C72 is its end address. So I'm just going to copy these. I'm just going to do it till Okay. 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 Yep. All right. So now I did that. So now let's test it. And lo and behold, let me put all this other stuff away. Lo and behold, the every object now is the dragon. So that's pretty cool, right? I mean, it's pretty sweet. Yep. So I mean, yeah, there you go. So save state kind of recorded before they were already there in RAM, so it didn't show up right. But once all that went away, it was just dragon. So here you see the palette is different because it's green, but it's because yeah, but still it's still pretty cool. If we go to another level, it'll look really weird because the palette's all odd. Yeah, so that's not too cool. But yeah, so it just looks odd at certain levels. But the first level, it looks pretty sweet. Dragons everywhere. Maybe that should be a name for this. But I hope you liked it. Um, like and subscribe. Leave some comments. What'd you think? Ask some questions. Just kind of sweet, kind of cool. Being able to figure out how a game works with a mechanism that I'm not really wasn't familiar with before this. Um, always learning. But hope you liked it. Sega Reverse Engineering.